So what we're going to be looking at here is Euler paths and circuits. And in this case, what we're trying to do is, for a network, we're trying to pass over every single edge without going back over a certain path or edge twice. So you have to cover every single possible path in the network without walking along one path more than once. So it's kind of like trying to make your way through the botanic gardens without going down a path you've already gone down before. You have to find a new way to get to every single place until you've been along every single path in the garden. So a key thing here is that no edge can be used twice. So once you've been down it, you cannot go down it again. And another one is that there is an Euler path and an Euler circuit, and these are similar in that we're trying to cover every single edge in the network without repeating any of the paths. But the difference here, the main difference here, is that we have, for a circuit, you must start and end on the same node. So start equals end on a circuit, and for a path, start does not equal the end. So for an Euler path might be that you start, maybe even at school you start at Manawahini and then you finish at the gym, versus an Euler circuit means that you start and finish from the exact same location. So wherever you started from, you end back where you started. And we'll see how these things play out. So what we were going to do is, I like this little tip they give in the workbook. If you can draw a path without lifting our pin or without going over any edge more than once, you have an Euler path. So if we take a look at these, if I started at A, go up to D, over to C, back down to A, over to B, and up to C, I have traced every single edge in that network, and I've not repeated any of them, so I've not gone back over myself. It is possible, again, like I've said here, that you can go through one node more than once. You just can't use one path more than once. So for instance, I started at A, went to D, then to C, then back to A, so I've already been to A, but that's okay, over to B, and then up to C, and I ended at C. So this would be an Euler path. And again, there would be different ways to do it, as they show in the diagram here, going from A to B, B to C, C to D, D to A, and then back over again. But in this case, our start and our end points are again different places, so it is an Euler path. Circuits, for instance, like I said, have to start and stop at the same node. So here, if I start at A, and I go up to D, over to C, down to B, and then back to A again, I've started and finished, or ended, at the same spot. So this would make it an Euler circuit, because you're back to where you came from. So there's a bunch of examples in here, but let's take a look and see at this one here. If I call the start up here, let's see how I go. So again, I can pass through nodes, but I'm just going to see if I can do every single edge without going back over myself. So it is just drawing out a star, like many of us know how to do. And you'll notice here that I can get across every single edge or path and start and end back at the same location. So this one would be an Euler circuit. So in this part of the workbook, they want you to basically determine whether or not you have an Euler path or an Euler circuit, or neither. So if you cannot get to every single edge without going back over a path you've already been down, then you cannot have an Euler path or circuit. So here you need to give a reason. They're asking for you to justify your answers. So we can take a look at number 1. Doesn't really matter where you start. And these are just spare diagrams for you to use if you want. So if you start here, 1, 2, 3, 4, and then here, what's going to happen if I go straight? So for instance, if I continue on straight, then I'm stuck because I can't continue on an Euler path because I've already used path 1 there. So that's not going to work. So let's think about going up first. So 1, 2, 3, 4, 5, 6. It's going up, across on 7, down on 8, and now at 9 I'm back to where I started. So this one would be an Euler circuit. And you could say because start and end node same. So for each of these, it's that same process. See if you can actually get yourself through the whole maze without getting stuck and without going down a path more than once. And if you start and end at the same spot, you know you have an Euler circuit.